squared minus 3/4. So in here I'm going to put square root of 4y plus 3 over 2. So when you square the square root, you get rid of the radical, but remember this 2 is not inside the square root, so that one is going to get squared. So this is going to give me 4y plus 3 over 4 minus 3/4. Since I have the same denominator right here, I can combine them, and we get 4y 3 plus 3 minus 3. So the 3's are gone. So that gives me 4y over 4, which, why am I writing y? Sorry, it should be x's. All of these should be, let me change the color. These should all be x's. And I have it, oh, I forgot to switch it over here too. It starts from way back here. When I switched it, I didn't switch the one in the radical. So these should all be x's. Okay? Go back to the blank marker, so it equals x. I apologize for that. And then the other direction is start off with the inverse. All over 2. And in that blank, I'm going to put in f of x. So x squared minus 3/4. So remember, we've got to distribute the 4 here and here. So that's going to give you 4x squared, it's still in the radical, minus 12 over 4, which is 3, plus 3 over 2. So the 3's are gone, 3 minus 3 is 0, and we have the square root of 4x squared over 2. Well, square root of 4x squared is 2x over 2. The 2's are gone, and we get x. So I have x here and x here. So because both compositions equal x, then I know that my inverse is correct and my functions are inverses of each other. Alright, I'm going to change the decimal to a fraction. So f of x equals 7/10 x squared. So now I'm going to restrict the domain, okay, and find the inverse. So f of x becomes y. I'm going to multiply both sides by the reciprocal of 7/10 so that I can cancel. Oops, that's a 10 out of 16 on this side. So I've got 10y over 7 equals x squared. So I'm going to take the square root. So plus or minus equals x. Okay? Again, because I chose this domain of positives, I'm going to pick the positive root. So x equals the square root of 10y over 7. And switch the x and the y. Okay, and then write it in proper notation. Okay, so now we're going to check the answer with composition. And so I'm going to take the f of x, and in the parentheses I'm going to put in f inverse of x. Okay, so when you square a square root, you get just the number inside. So 7 over 7 is 1, 10 over 10 is 1, so I'm left with x. The other direction, we start off with square root of 10 times and then over 7. Now in the parentheses I'm going to put in the f of x function. So 10 x squared. So 10, this is 10 over 1. So 10 over 10 is 1. And so now I have 7x squared over 7 in parentheses. So the 7 over 7 is 1. And so now I have x square root of x squared, which is x. So both of them gave me x, both compositions, so my inverse is correct, and so they are inverses of each other. Okay, for page 15, number 2 and 4, they just want you to describe the transformations from the parent function to this new one, g of x. So right here, this is b, and this is k. So I would say that this one has a horizontal stretch, by a factor of 2. Because remember, you take the reciprocal of b. And then the plus 1 means that it translates or translated 1 unit up. Okay, for number 4, the a is 1/4, the h is 5, and the k is -2. So this has a vertical compression by a factor of 1/4. Okay, so for a, you do what it says. There's no reciprocal there. And then you're going to move right 5 and down 2. Okay, so on number 6, notice how we only have a b and an h. The a is 1 and the k is 0. So x does not change at all. So, I'm sorry, y does not change at all, but x does. So since b is 1/3, we take its reciprocal, 3 times 0, and then plus 1, because we do the opposite of what h says. So plus 1, and then the that bigger one right there, and the y stays the same. It has no transformation. The next one, 3 times 1 plus 1, and the y stays the same. And then 3 times 4 plus 1, and the y stays the same. So let's simplify. So 3 times 0 is 0, plus 1 is 1. And then 3 times 1 is 3, plus 1 is 4. 3 times 4, 12, plus 1 is 13. Okay, so remember, x is your domain and y is your range. Okay, so when they ask you for domain and range, domain, we look at the x's. Remember, this is the dot. Oops. This is the dot. So that's where it starts. So, let me go ahead and draw that. So, it starts on 1, and the numbers are getting bigger. So it's from 1 to infinity. The range starts on 0, and the numbers are also getting bigger. So it's from 0 to infinity. And notice h is 1, k is 0, domain 1, range 0. Okay, so on this one, it has a b, it has an h, and a k. A equals 1, so it doesn't affect, it doesn't do any transformation. So the y's are increasing by 2 because k is 2. So I'll just put a little plus 2 right here. The x's have 2 changes, so I'm going to just write them out. So I'm going to multiply the x's by -1/5 because you take the reciprocal of 5. So -1/5. And then we're going to subtract 1. Okay, and then 2 plus 0 is 2. So -1/5 times 1 minus 1. And then 2 plus 1 is 3. And then -1/5 times 4 minus 1, and then 2 plus 2 is 4. Okay, so let's simplify the points. 0 minus 1 is -1, then 2. -1/5 minus 1 is -1 1/5, 3. And then -4/5 minus 1 is -1 4/5, and 4. So notice the x's start at -1 and they're getting smaller. The y's start at 2 and they're getting bigger. So for domain, we start at -1. Oops, sorry. Since they're getting smaller, you actually start with -infinity up to -1. Okay? And for the range, they start at 2 and go to infinity. And again, notice h is -1, domain -1. K is 2, range is 2. Okay? Okay, so for this function, there's a reflection over the x-axis, and then it's shifting up or moving up 3 units. So the a and the k affect the y, not the x, so the x is going to stay the same. And then the y gets multiplied by -1 and then added 3. Multiply by -1, add 3, and then multiply by -1, add 3. So we simplify that, and we get 0, 3, 1, 2, and 4, 1. Okay, remember this is the dot, and this is the arrow. Okay, it doesn't look like arrow, but it's arrow. Okay, so I drew the parent function as they asked you to do, to graph the parent function and the g of x also. So this is the parent function, f of x equals square root of x. And now we're going to plot the transformed points, 0, 3. Oops, let me change the color, sorry. 0, 3, 1, 2, and 4, 1. And remember, the dot is on 0, 3, the arrow on 4, 1. So it goes something like that. Okay, they also want domain and range. We could do it from the picture, or we can do it from the table like we did 6 and 8. So if I look at the table, I have starting at 0 and going up for the domain, starting at 3 and going down for the range. So the domain starts at 0 and goes on up. The range goes from -infinity to 3. And it matches what we see on the picture too. Okay, remember B and H affect the X, and K affects the Y. In this problem, A is 1, so A doesn't change anything. So I'll just put a -2 right over the Y's. And then for the X's, there are 2 things we're going to do. We're first going to multiply them by -3/2, because it's the reciprocal of -2/3. And then we're going to add a half. Oops, that's a messy half. Okay, and then -2 plus 0 is -2. That's for the y. So -3/2 times 1 plus 1/2. And then -2 plus 1 is -1. And then -3/2 times 4 plus 1/2. And then -2 plus 2 is 0. Okay? We could simplify this now. 0 plus a half is a half. -2. And then -3/2 plus 1, that gives you -2/2, which is -1. And then -6 plus a half is -5.5. 0. Okay, so there's your new set of points. Now we're going to graph it. Alright, so here we have again the parent function, f of x equals square root of x. Now we're going to plot the g of x function, so it's 1/2 -2, -1, -1, -5.5, 0, so about here. And remember, this is the dot, and this is the arrow. Or just, you could just put arrow. Okay, so it goes something like that. Okay? The domain and the range, again, we could look at the points and go from there like we did in the earlier problems. Starting at 1/2, the numbers are getting smaller and smaller. Starting at -2 for the range, or the y's, the numbers are getting bigger and bigger. So you would say from -infinity to 1/2, and then from -2 to infinity. Remember, when the numbers are getting smaller, you start with -infinity, because you're going from from larger to smaller. The numbers are decreasing. So we could see it from the graph. And another thing, notice again, I forgot to mention it on the other problems. I did at the beginning, but I didn't do it on the in-between ones. H is 1/2. Your domain starts at 1/2. K is -2. your domain starts at negative 2.